6.2, which is graphing quadratic equations to find the solution. When they talk in the problems, they're going to talk about you finding the roots, the x-intercepts, the solution, the zeros. That all means find the same thing. Where am I crossing the x-axis? What's my solution? We're going to start by looking at problem 21, which is a negative x squared plus 4x equal to 0. I know from looking at it, my a value is negative, so that means I'm going to open down. I also know from lesson 1 that I can find my vertex by using the negative b over 2a y for my ordered pair. So let's start by finding that. I'm going to plug in the negative 4 over 2 times negative 1. Simplifying it up, I get a 2. I take that 2 and I plug it into my quadratic equation. So I have a negative, parentheses, 2 squared plus 4 times 2. And when I simplify that up, I come up with a 4. So my vertex is at the point 2, 4. Which means my axis of symmetry is also at the equation x equal to 2, because the x value of the vertex is the same as the axis of symmetry. I also know that because I don't have a c value, my y-intercept is 0. Now, because I'm 2 away from my line of symmetry, I can go 2 on the other side. I have another point. Again, the graph's opening down. There's my graph. Now, what I'm looking for the solution is, I'm looking for where do I cross the x-axis. So I have 2 points where I cross the x-axis. I have the point at 0 and the point at 4. So when I go and write the solution, I write it at 0, comma, 4. There's my solution. Looking at another problem, we're going to look at problem 33. Same directions, we're going to go and solve it. Again, when I'm looking at it, we need to find that negative b over 2a y, so I know where my vertex is. So I plug in a negative 4 into the b. I plug in a as a 1. And when I simplify up, I again get a 2. Plug in the 2 in, I'll have a 2 squared minus 4 times 2 plus 2. I get a value of negative 2. So my vertex is at the point 2, negative 2. This one's also going to open up because my a value is positive. My axis of symmetry is at x equal to 2. And the ordered pair for the vertex again was 2, negative 2. This time I have a y-intercept. It's at that c value, which is 2. So I'm going to put my y-intercept at 2. Because I'm 2 away from the axis of symmetry, I'm going to go 2 on the other side to get a second point. And I'll be able to go in. If I want to find a third point, I can go in. If I plug in a 1 using my graphing calculator, I find out if I plug in a 1, I'm at a negative 1. Which means if I plug in a 3, I'm also going to be at a negative 1 because of the symmetry. Now, when I graph it this time, I notice that I'm not hitting an integer. So when you don't hit an integer, you have to give the integers it's between. So my first point is going to be between 0 and 1. The second point that I'm looking for the solution is between the point 3, 4. So when you're asked to not get, if you don't have an exact solution, that's how you give your solution. And then our last problem for this lesson is use a quadratic equation to find 2 real numbers that satisfy each situation or show that no solution number exists. We're looking for a sum of 12 and a product of 28. So when I look at it, x is going to be my first number. Because the 2 numbers have to add up to 12, I'm going to use 12 minus x for my second number. Write an equation for it. I'm going to have x times 12 minus x is equal to negative 28 to show the product. Go in and use my distributive property. I have 12x minus x squared is equal to negative 28. Setting it up to solve, I have a negative x squared plus 12x plus 28 is equal to 0. Coming in, using my negative b over 2a again, I can find my x coordinate, a negative 12 over 2 times negative 1. I come up with 6. My ordered pair would then become a 664. When I'm looking at it, after I plug the 6 in. Now, if I'm looking at my chart, I can even get by without graphing. If I start looking at my chart, we know that we know that the y-intercept is going to be a 28. If I plug in the 6, I'm at 64. If I plug in a 12, I'm at 28 because there's that symmetry going on. When I go a little bit farther, if I plug in a 14, and again using my graphic calculator can help me come up with this, I have a 0. And if I put in a negative 2, I'm also at a 0. Again, you're looking at the symmetry going on here. So I have my two ordered pairs there of negative 2, 0, and then a 14, 0. So that means my solution would be a negative 2,